Let's consider some more u-substitution problems. And we'll start to see some that involve some tricks, so to speak. Here we have the integral of x plus 2 times the square root of x squared plus 4x minus 3 dx. X squared plus 4x minus 3 is more complicated, so we'll say that u equals that function. This means that du equals 2x plus 4 dx, and if I divide both sides by 2, then half of du equals conveniently x plus 2 dx. So now I can make the necessary substitution. This means that I'll have the integral of 1/2 u to the 1/2 du, and when we integrate that, we'll have u to the 3/2 power. 2/3 times the leading coefficient 1/2 is 1/3. So 1/3 u to the 3/2 plus c, and converting back to x, 1/3 times x squared plus 4x minus 3 to the 3/2 power plus c. Now we get to example number 10, which is the first one that has a trick to it. So x plus 2 times the square root of x minus 4 dx. And the first thing that you might notice is that x plus 2 and x minus 4 are both first degrees, which means that if I let u equal x plus 2, what I won't get is anything involving an x minus 4. And if I let u equal x minus 4, again, I run into the same problem. So there is a trick, so to speak, to help us deal with this problem. Now, since x minus 4 is in the square root, it is the more complicated of the two, so I will let u equal x minus 4. And this does mean that du equals 1 dx. But how are we going to get the x plus 2 there? Well, notice that if we take u equals x minus 4 and add 6 to both sides, this means that u plus 6 equals x plus 2. And now we can make all of our substitutions. Because when we do this, well, I'll replace x plus 2 with u plus 6. And I'll replace x minus 4 with u, so this will be u to the 1/2 power, and I'll replace dx with du. Now I can just distribute, and this becomes u to the 3/2 plus 6u to the 1/2 du, and I can integrate that. That's equal to 2/5 u to the 5/2. That would be u to the 3/2, and 2/3 times 6 is 4, plus c. And finally, to finish the problem, we convert everything back to x. So again, this is 2/5. And remember that u equals x minus 4, so I've got x minus 4 to the 5/2 plus 4 times x minus 4 to the 3/2 plus c. There's two more examples. You might try them yourself first. So in example 11, real similar to number 10, we've got the integral of x minus 5 divided by the square root of x minus 6 dx. X minus 6 in the square root is more complicated, so u equals x minus 6. This means that du equals 1 dx. This also means that if I add 1 to both sides, that u plus 1 equals x minus 5. So now I can make my substitution. This will be u plus 1 over u to the 1/2 du, and this simplifies into u to the 1/2 plus u to the negative 1/2 du, and when I integrate this I'll have 2/3 u to the 3/2 plus 2u to the 1/2 plus c, and going back and substituting in for u, which we said was x minus 6, we would end up with our final answer. Last example for this section, x squared over the square root of x plus 1. The integral of x squared over the square root of x plus 1 dx. How will we approach this? I need to use a similar idea. I'm going to let u equal x plus 1, and this does mean that du equals 1 dx, but I still need to get that x squared from somewhere. The only thing I can use is u equals x plus 1. If I subtract 1 from both sides, then this means that u minus 1 equals x. And so now I can replace everything. When I substitute in, this means that I'm taking the integral of u minus 1 squared over u to the 1/2 du, and u minus 1 squared is equal to u squared minus 2u plus 1, and all of that is being divided by u to the 1/2 du. So I can simplify this a bit further into u to the 3/2 minus 2u to the 1/2 plus u to the negative 1/2 du. And now I'm ready to integrate. This will end up being 2/5 u to the 5/2. This would have been u to the 3/2. 2/3 times negative 2 is negative 4/3 u to the 3/2 plus 2u to the 1/2 plus c. And now just going back and substituting in for u. When u is x plus 1, I have this function, which I'm very glad I could use the chain rule on. I'm not sure, or use u-substitution on, and I'm not sure I would have wanted to use the chain rule to take its derivative in the first place. So 2 times x plus 1 to the 1/2 plus c. The remaining 2 videos will deal with trig identities in u-substitution and also deal with any tricks on those.